Okay, this is lesson 6.4, which is negative and zero powers. Okay, so we're going to go through a little investigation first. What is the value of something raised to the zero power? So something that looks like this. Okay, we're going to go through this two different ways. First, we're going to use the product of powers property that we already know. So we know, looking at this, that 5 times 1 is 5, 10 times 1 is 10, and x times 1 would be x. Using the product of powers property, we know 5 to the 4th times 5 to the 2nd power is 5 to the 4 plus 2 power, which is 5 to the 6th power, right? X to the 8th times x to the 5th would be x to the 8 plus 5 power, which is x to the 13th power. Okay, so we're going to put these together. Therefore, 5 to the 4th power times 5 to the what power would be 5 to the 4th power. Well, we would be adding 0, so this must be 5 to the 0 power. Or we know that 5 to the 4th times 1 would be 5 to the 4th. Anything times 1 is itself. So what does this mean? This means 5 to the 0 power is 1. Let's look at it again. X to the 8th times x to the some power is x to the 8th. We would be adding 0. So this would have to be x to the 0 power. Well, we know that anything times 1 is just going to be itself. So that means x to the 0 power is 1. 5 to the 0 power is 1. X to the 0 power is 1. So hopefully something made sense, but if it didn't, we're going to look at it using the quotient of powers property, see if that makes sense. We know that 6 divided by 6 is 1. X squared divided by x squared is 1. Anything divided by itself is 1. We also know that 6 over 6 is 6 to the first power divided by 6 to the first power, right? If a number doesn't have an exponent, like say 8, we actually know that that exponent is 1, even though it's not there. So using the quotient of powers property, which if you remember, we subtract the powers. This is 6 to the first power divided by 6 to the first power, which is 6 to the 1 minus 1 power, which is 6 to the 0 power. But remember, we also know 6 divided by 6 is 1. So 6 to the 0 must equal 1. These two things are equivalent. X squared divided by x squared would be x to the 2 minus 2 power, which is x to the 0 power. But again, we know anything divided by itself is 1. X to the 0 must equal 1. 6 to the 0 must equal 1. In fact, any number to the 0 power is always going to be 1. 206 to the 0 power is 1. A smiley face to the 0 power is 1. So when you do these 4 examples, guess what? 11 to the 0 power, 1. 121 to the 0 power, 1. X to the 0 power, 1. Y to the 0 power, 1. So that's investigation number 1. Investigation number 2 is what is the value of something raised to the negative power? So to a negative power, like x to the negative 1. Well, we're going to use a quotient of powers property to see if it makes sense. We know that x to the first divided by x to the fourth the denominator has the larger exponent, so we're going to subtract the exponents, but leave them in the denominator, which is 1 over x to the third power. Okay? So if you just subtract, ignore whether the exponent goes in the numerator or denominator. In fact, if we put it in the numerator, instead we do x to the 1 minus 4 power, which is x to the negative third power. But again, we know that this equals that. So we know x to the negative third equals 1 over x to the third. So what does that mean negative exponents do? Negative exponents move things from a numerator to a denominator. which means negative exponents make things the reciprocal is the key. Right? This was x to the first, negative first, over 1. So we flip it and make it positive. Let's do a couple examples. I'm going to do the first one. You're going to do that one. What I like to do is I like to highlight the base with the negative exponent. So this is 5 to the negative second power. The negative 2 is going to make this the reciprocal, so it's in the numerator, so we'll put it in the denominator. But we know what 5 times 5 is, which is 25. You should do this one. Check the answer key. For number 2, this is 3y to the negative third. The negative 3 power is only with the y. The base is the y, because 3 actually has a positive 1 power. So the 3 is going to stay in the numerator because it's not moving. It has a positive exponent. The only thing that's moving is the base with the negative exponent. So this should be 3 over y to the third. We'll do a couple more examples. Number 3. Again, I'm going to highlight all the variables that have a negative exponent. So C has a negative exponent. So anything that has a positive exponent, I'm going to write in the numerator because that's where it is. And then the denominator is going to have the C to the 7th because it has a negative exponent. So that's the only one that moved. This one, I'll do this really quickly. I'm going to highlight only the bases that have a negative exponent. I'm going to rewrite the 6 y to the 5th in the numerator because it's not moving. It has positive exponents. Then x squared will go to the denominator. Z to the first will also go to the denominator. Number 4 is really touching on the fact that this is a negative exponent, and negative exponents make things reciprocals. So the reciprocal of 2/3 is 3 over 2. So what I did is I made the reciprocal, and then I took the negative sign off because I flipped it. Now I can raise the numerator to the third power and raise the denominator to the third power. 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. You can do that one on your own. For number 5, I'm actually going to do this. Yeah, here we go. So the base that has a negative exponent is just that m to the 4th. I'm going to rewrite everything that's staying in the numerator. And then the only thing that's going to the denominator is m to the 4th. Now this becomes just like every other problem. We still need to simplify. 5 times 3 would be 15. M to the 9th. Over m to the 4th. Anything over itself is 1. I'm left with 15 m to the 5th, no, sorry, m to the, 5th power. Do the next one on your own. Number 6, again, I'm only going to highlight the number that has a negative exponent. Now, this one has a negative exponent in the denominator. So what I'll do is I'll rewrite everything that has a positive exponent, 6x to the 3rd, z to the 5th, over 8x to the 5th, right? Those aren't moving because they have positive exponents. However, this negative 4 makes it a reciprocal. So if it's in the denominator, it's going to move to the numerator. From here, we simplify as usual. 3 times 2, x to the 3rd, z to the 5th, z to the 4th. All over 4 times 2, x to the 5th. we're left with 3z to the 9th over 4x to the 2nd. Then you should do the last one on your own. Check the answer keys if you need some support. Now, the couple things that I want you to remember is you want to always, at least I think the first step, is to rewrite the problem with only positive exponents. That would be my first step, is to always move the problem so that it has positive exponents. The second thing is to always remember that the negative exponent, well, I guess you should ask yourself a question. What is the base with the negative exponent? And again, I say this because of problems like 2x to the negative 4th power. The negative exponent is only applying to the x, not to the 2. Okay? And then the last thing that you want to keep in mind is just something that I forgot to do in the examples, is anything to the 0 power is 1. Just remember those key steps and you'll be okay.